Hello everyone, and welcome to today's webinar. We appreciate your taking time to spend an hour with us today learning about integrated math. Our featured speaker today is a teacher. This is the beginning of our Teacher-to-Teacher series on math, the model math curriculum. Our teacher today is Anita Reed, and Anita has been a curriculum writer, and now she helps to provide professional development for the model math curriculum. She currently teaches Math 1 at Lewiston High School, and we're just really glad that she can be here. With me in the studio today is Roxanne Filson, who's the Director of Special Projects for the Illinois State Board of Education. I'm going to turn this over to Roxanne for a few words.
Hello and welcome. We are pleased to be able to present an Illinois math educator who will highlight the model math curriculum and its real classroom application. The Illinois State Board of Education is pleased with the dedication and the expertise of many teachers who have worked to make this project a success. This project's content lead is Jenny Winters, math consultant for the Lake County Regional Office of Education, who was assisted by Diane Beatty and Linda Brissenden.
We're going to begin with a short survey, and then we'll turn it over to our presenter, Anita. It's always good for a presenter to know who her audience is, so let's take a survey.
Okay, you may now select item 1, 2, or 3.
Okay, as you can see, 68% have seen the resources on ISBE website, and that's just terrific news. And so, Anita, you're going to have an audience that will at least know what you're talking about when we're starting out of the gate. So we're going to turn it over to you, and we're looking forward to all that you have to share.
Thank you, Linda. I want to welcome everyone to today's webinar, Integrated Math, Lesson Examples, and Student Samples from the Classroom 912. As Linda said, I am Anita Reed, and I have been involved with the ISBE Model Math Curriculum team since it began in October 2012, first as a curriculum writer and now as a provider of professional development. Currently, I teach Integrated Math 1 at Lewiston Community High School, and I'm glad to be here to share with you my excitement for this curriculum and the positive impact it has had on my students. Today's webinar will focus on reviewing the ISBE Model Math curriculum, looking at a specific lesson from Integrated Math 1, taking a look at the backward design of this lesson, the assessment plan, some student work samples, and particularly highlighting the math content and practice standards assessed in this lesson. If you are unfamiliar with backward design, we will address this as we progress. So what is the ISBE Model Math Curriculum? It's a K-8 and high school integrated math 1, 2, and 3 framework. Each course has a specific scope and sequence, and there are unit overviews for each course, as well as assessments, model lessons, the lesson documents required to carry out those model lessons, and family letters to assist with communicating with families. We will look at each of these components specifically when we look more closely at today's featured lesson and also later in my binder. But first, let's briefly review the purpose, process, and philosophy of the Model Math curriculum. The purpose of the ISBE Model Math curriculum is to serve as a framework or resource to assist teachers in the implementation of standards-aligned curriculum and instruction. Students may choose to adopt, adapt, or ignore this framework. The scope and sequences have been aligned with PARC according to the blueprints for success on the EOY, which is the end of year, and the PBA, which is the performance-based assessment, using the progressions documents and evidence tables. Now, the progressions documents link current content in a particular unit to prior and subsequent learning, whereas the evidence tables are referred to as they sort the content that will be assessed on either the PBA or EOY. And they allowed the writers to order the scope and sequence such that content would be covered in a timely fashion for when it was assessed. PARC requires a performance-based assessment to be administered at approximately 75% of the year, and then an EOY end-of-year assessment at the 90% completion mark. So what is the process to develop this curriculum? The development team is divided into grade level or high school course teams. Teachers from throughout the state of Illinois have been involved. They meet and develop the tools using the process described today. Whenever we meet in person, there is a time dedicated for peer review. Teams review another grade level or course's recently developed documents and provide feedback. The team then make revisions based upon that feedback. We then electronically send documents to a team of over 500 reviewers who fill out an electronic survey within a 7 to 10 day window. The team is given a report of the information from the external review and uses it to make revisions. The documents are then sent to an editor who corrects errors in grammar and mechanics. Edited documents are sent to pilot teachers. At the same time, they are made public. Pilot teachers are collecting student work samples and teacher reflections that will be reviewed by the development team towards the end of the school year once all of the units have assessments and model lessons. As you can see, the process has been thorough and has involved many professionals. Some of the lessons have been rated as exemplary by national experts. The philosophy of the model math curriculum is that the units will focus on the math that needs taught, resulting in fewer topics, that coherence will link topics and be present across grade levels, and that rigor is present in a balanced representation of conceptual understanding, procedural skill, and fluency, and application. The UBD focuses on teaching for understanding using the backward design of writing assessments first and then developing the lessons to teach those concepts assessed. As a quick review, UBD stands for Understanding by Design, which is a tool used for educational planning. It is focused on teaching for understanding and advocated by national assessment experts Jay McKeag and Grant Wiggins. UBD emphasizes a backward design, or looking at outcomes first in order to design curriculum units, performance assessment, and classroom instruction. UBD has 3 stages. Stage 1 focuses on desired results. What do we want students to know or be able to do? Stage 2 focuses on assessment. How will we know that students know and are able to do whatever? Stage 3 focuses on the activities that students must engage in order to reach the desired outcome measured by the appropriate assessment. Next, we will look at Live Binder, which is the online host that houses the ISB Model Math Curriculum resources. We will focus on examples of the following components: a summative assessment, an assessment plan, task and formative assessments, and lesson plans, to examine the backward design of these model math curriculum units. Essentially, the writers begin with the content standards for each unit and write rich assessment items. From there, the assessment items are sorted into a CPA, which stands for Conceptual, Procedural, and Application document, also known as the assessment plan. And then lessons are written to teach these standards while also incorporating math practice standards. To review, an example of a procedural task would be one that requires knowing how to perform some mathematical task. For example, multiply 24 by 8. A conceptual task requires knowing why we performed the task in that way. For example, estimate the product of 24 and 8 and justify your answer and method. And finally, an application is being able to use and apply this method in the context of a real-life problem. For example, if there are 200 chairs in the storeroom, are there enough to set up 8 rows of 24 for tonight's choir performance? Justify your response. I want to mention right now how we can find the Live Binder, which is where all these documents are stored. And I can walk you through this right now. To begin, we want to go to isg.net, and once there, we want to choose Common Core and ELA Math from the far right. And again, once there, we want to go all the way to the right and choose Model Math Curriculum Unit. And finally, when you scroll down, you'll be looking for this yellow box, and this is where you will click to go to the Live Binder containing all the documents previously mentioned. In addition, you can also go to IllinoisClassroomsInAction.org, and that's actually fewer steps to get there if you choose this route. Once you click there, you will simply scroll down to find the green button, and clicking on the green Model Math Curriculum button will take you there as well. So those are two ways that you can find Live Binder at any time. Okay, as we mentioned with the backwards design process, we start with assessment. You know, we examine the content for that particular unit, and we begin writing the summative assessment. I'm going to show you an example of a summative assessment for a Math 1 class, Unit 4, which is interpreting functions. This will also give you some experience in navigating the Live Binder site. For example, this is a Math 1 course, so we will choose Math 1. We will scroll down to Unit 4, Interpreting Functions, and then we see these various tabs. Well, since we're starting by looking at the summative assessment, we will click on the Assessment tab, and now we will click Summative Assessment, and here we have one. Now, looking at this summative assessment, we can see many rich items incorporating the application of standards from Unit 3, along with providing an opportunity to demonstrate understanding by creating and explaining components of a function graph based on features learned in that standard. By rich items on the assessment, I mean items that do not solely assess conceptual or procedural knowledge, yet one that provides rigor for a specific standard, as well as incorporating one or more math practice standards. So, for example, this example right here, we would show a video, and the students have to graph their heart rate on the X and Y axis. They have to label it and graph their heart rate over time as to what they interpreted their heart rate did based on watching that video. And then below that, they have to write a paragraph describing what they graphed. This is their own interpretation of the function that they just graphed. And then they do various function tasks, such as estimating rate of change at key points and explaining how and why the rate of change varies throughout the key points of the scheme. We often see multiple examples of real-life situations on these assessment items, and I would like to bring that up and the next question. In this real-life example is about a taxi cab driver and the path that the taxi takes along a typical ride, starting and stopping. Students have to interpret this function as well and graph the result again, and then from there they also answer other function questions that pertain to that graph. And so not only are we providing real-life examples, but we're connecting them to the standards. From here, we will look at our assessment plan to further understand the backward design of this lesson. As the team writes various tasks and the mini assessments, that would be the pre-assessment, self-assessment, formative and summative assessment, they know both which content standard is addressed on each assessment and on which assessment it is addressed. And we mark these on, I mentioned earlier, the CPA document or the assessment plan. Now that's going to be found in Math 1 Unit 4, just like before. And so this assessment plan right here. So we have the Math 1 Unit 4 assessment plan. And on that will be a list of all of the content standards that are going to be assessed for that unit. And as you can see, there are 3 green standards and 1 blue standard. And so, for example, let's just look at the standard. For FIS 4, we note that we assess for conceptual understanding of that standard on the pre-assessment and the Math Museum, as well as the summative assessment. We assess for procedural skill and fluency understanding on the pre-assessment, self-assessment, Math Museum, and summative assessment. And again, we assess application on the Math Museum, the roller coaster, and the summative assessment. The matrix is utilized in this way to ensure that assessments contain an equal balance of conceptual, procedural, and application items. And when these items were written, we were careful to be sure we included all the types for each standard on the assessment. Note how this aligns with the state's emphasis on balanced assessment, different types of assessment for different purposes at the beginning, along the way, and at the end. I next want to show you tasks that we use, and this next link is going to open the Math Museum Task Informative Assessment. Now, I believe this was made available as a handout so that you could follow along so that we wouldn't get confused and clicking back and forth. If you have that handout, please take it out now. This actual task informative assessment will be under the assessment tab, and we will click Math Museum as that is its title. And what you should have on your handout and what I have on the screen is the Math Museum. It opens with 8 stations containing real-life data represented in charts and graphs. And I cannot stress to you how valuable it has been for these students to know that this is real-life data and not something made up to look nice in a textbook. They really value the fact that it is real and it allows this connection like they really didn't believe they could. In addition to the 8 charts and graphs, there are 8 sets of questions to answer as the students proceed through the stations in groups of 2 to 3, depending on class size. Now, often in my classroom, we work through Station 1 questions together, and I ask extension questions as we proceed. This is to set the expectation for detailed answers for Stations 2 through 8, and in my experience, has helped the students, especially those who are still transitioning to the new Illinois Learning Standards. Now let's take a closer look at Station 1. Okay, what you're seeing is a smaller version of the graph and the first 3 questions from Station 1. Now these graphs would be taped at various locations around the room, and students would travel between the stations after every 7 to 10 minutes, depending on how long it takes them to answer the questions and form detailed answers. Now let's examine the questions that are posed for the students to answer, and we'll take a moment to look at your graph while I bring up some actual student replies. So in Station 1, the question number 1, does the graph represent a function? And as you can see, I did a simple yes it does to a student who is maybe still working on developing those clear communication skills and justification responses to yes it does represent a function because you can do the vertical line test and only hit 1 point. Now I do want to mention here that because in Station 1, as you can see on your handout, we don't give an actual table of data, so they were not able to see specifically inputs and outputs to know that the inputs had not repeated, with a separate output. So they basically only had the picture of the graph to base their reply on, and usually do a pretty good job with that. Question 2, if so, is the function increasing or decreasing? If not, justify your answer. And so here we get into that math practice 7 of justifying our responses. And so one student says, it is increasing because the line keeps going up. Another says, it is increasing because the slope of the line keeps getting steeper. And that's probably the most detailed answer that I got. And yet a third says, it is increasing because the population is more at the end of the graph. And clearly, this student justified his response, and it was very telling of at least showing some understanding Now, most of the students all understood immediately that the graph was increasing, but I did probe a few questions in order to get them to justify why it was so. Moving on to number 3, what does the graph tell you? Now, I want to mention here, and this is very important, that a form of question 3 shows up at every station and is, in many ways, the ultimate unit question for Unit 4. I stress to my students that initially they may not answer this type of question completely or specifically, but that our goal for this test would be that by the end of 8 stations, they are answering with much more detail. These higher order thinking questions not only require them to have math knowledge, such as slope, increasing, and decreasing, but also to apply that to real life population, for example, and determine what the data means in the context of the real life situation and therefore interpret functions. So as you see, one student who was still working on putting responses together answered just population. And another student answered that population increases over time in billions. Another student just interpreted what the graph was doing. The population goes up overall, but starts to level out at the end. Another student observed that each time they recorded the population, it had gone up by 1 billion, but it took a different number of years to reach 1 billion each time. And I thought that was a very keen response. That student did not have the language to discuss slope, but yet still made a valuable observation that demonstrates understanding. And lastly, the population since 1700 increases slowly at first and then more rapidly from 1960 on. So as you can see, students are interpreting these graphs in many different ways and using many tools that they come to class with and previous knowledge. Question 4, what are the 2 variables in the situation, the independent variable and the dependent variable? Again, most students did well with this question, the dependent variable as population and the independent variable as years. And I often note to the students that they should be specific with their independent and dependent variable, noting any labels in their responses. So I would, if a student answered to me population, I would say be more specific. In fact, that I was looking for in billions. Question 5, using statistics, the person who collected this data from years ago was able to predict the population of the Earth for any given year. We currently have 7,071,159,505 humans living on Earth, with more being born each second. According to the graph, was his or her estimation accurate? Why or why not? Now, I do remind the students that this is an interpretation of an estimate. And so, of course, they're going to answer yes or no, but the kicker is they have to justify why or why not. So one student says, no, it's not a good estimate because it is 2015, and the graph says we should have way more than 7 billion by now. And another student says, yes, it is a good estimate because a few years past the 7 billion mark could be this estimate. It is just an estimate, and it does sound close. Then some questions that I often ask, because I always want to probe the students just a little bit farther. These questions are not on the handout, but I do pose these questions, especially when I see that they're very involved with this one graph, and we've now spent 20 minutes or more diving into and interpreting the mathematics in this graph. While I have their attention, I ask, what could have possibly happened to explain the increase in population in 1960? And why is it helpful to predict the Earth's population in the future? It's always interesting when the students' answers are cross-curricular. For example, at one point they mentioned the baby boomers, and in another example, someone mentioned the grapes of wrath in their response. And I can't tell you as a teacher how awesome it is to see the math meaning something to the students and to hear their math conversation as it applies to other subjects. So as I mentioned, some possible answers for question 6, students that replied that the baby boomers in 1960 were simply having more babies, and so that contributed to the growth. Other students decided that There were more medical advances, and that meant less deaths. And along with that, we were vaccinating more, which was also preventing disease and subsequent death. Question 7, and this was also good to tie to science class, students said it was helpful to predict the Earth's population to know if we have enough natural resources, and so we know if we can make enough food to sustain that many humans. And lastly, I asked them, what could be the reason for the decrease in population growth, as in smaller slope but still growth, between 2024 and 2048? Here again, the thought-provoking follow-up requires students to go back and look at the data in the context of the question and make a connection to possible real-life circumstances in the future. I tell them this is when they will use their understanding of math in the future. Since we often get the question, when will I ever use this? And again, the math conversation that takes place leading up to these conclusions illustrates knowledge way beyond just skills. This task then includes 7 more stations like the one we just demonstrated. Their responses are, possibly the population grew at a slower rate because there was Ebola or some other epidemic. Of course, Ebola is the most current epidemic in their minds right now, so that's what they replied. Possibly there was a volcano eruption or some other natural disaster, or even worse, a nuclear bomb, and of course they were thinking about terrorists. But it's an amazing feeling when they can not just grudgingly go through their math assignments, but when we hear them relating it to, for example, science or current events. I can't accurately describe the feeling as a teacher.
Anita, we've had a couple of questions here about this process. I'm wondering if you could speak to how are the groups or pairs that are working through these stations, and how do you get assessment grades, or how do you go about grading the work that the students are doing?
You know, it depends on the class size. For example, I have a couple of classes with 21 or so in them, and since there are 7 stations left, then at most I have 3 students working together at a time. In some of my smaller classes, they will partner up in just 2s, but we won't have everybody at a station at one time. I have found that in general, it works better for them to be able to bounce these higher order thinking responses off of each other as they work through, whereas most of the time a student working on his or her own will be hesitant and not confident, and as you know, students get ideas from one another and then add to that. I will say on occasion I have had a student or 2 who says, you know, is it okay if I'm just my own group? And I have that as well. But more often than not, it works well to have them in at least pairs as they rotate through the station. Now, as far as assessing, we assess these in different ways. One, I'm constantly walking around the room to listen to the conversations and, of course, make sure everyone is participating. And I have to tell you, on days that we walk around and have stations, I don't have much of a participation problem at all. Kids are happy to be out of their seats. They're glad that it's real data. Oftentimes, they'll ask questions of me about the data. For example, one of the other stations is about bacteria, and another is about Facebook, if you can believe it. And so they are very intrigued by the data, and it really holds their attention as they move through the station. There is an assessment tool that I did not bring up, but I can show. It's called the observational checklist, and it's a tool that you write each student's name on, or I do initials if I can keep them all straight. And then you mark on there as you observe and walk around the room whether the students are emerging, whether they need practice, or whether they have mastered the standards as assessed in these stations. So the observational checklist is a tool we use to assess. But I will also say that there's a follow-up activity to the Math Museum, and it's also housed in LiveBinder. It's entitled Math Museum Extension, and that is something that they do independently at their seat. So that would be a document you would collect.
One other question, Anita, is have you found that teaching integrated math in that format works better for one demographic group of students than another?
I find that, well, for example, students with IEPs really have demonstrated, how do I put this, whereas they would come to class and perhaps be intimidated, they have really participated more. And once we have a little bit of success, they are more willing to participate even further from that point. And so I would say that that group, I have noticed the integrated math reaching. I have middle-of-the-road students as well who really enjoy the hands-on. They also seem to really be appreciative of the real-life data. But at the same time, my proficient learners, as well as some of my gifted students, also really enjoy this method because they can ask those questions. And, you know, say they get through the station, we can give them extension questions, or we can challenge them with further questions even. And so it's also been lending itself to differentiating across all levels, actually, from the entry level to, you know, like I said, the gifted learners.
One other question, Anita, is how did you just decide to do integrated, and how's it set up within your school setting?
Well, we kind of examined our math curriculum here at Lewistown, and we knew we had some math deficiencies. We knew we had a certain population of students that it didn't seem that were consistently not being reached. And so between my involvement with the model math curriculum and along with my administrator's cooperation and research and then discussions with the department, we decided that this was something we wanted to make available for our students. In addition, I guess backing up before that, we decided that the scope and sequence itself was very valuable as it was laid out, whether we completely went integrated or not at that point. This was initially. We thought that the scope and sequence made complete sense, and so we more or less adopted that first. But in so incorporating integrated math tasks along the way, we decided it was some really great stuff. And the more we used with our students, the more the students bought into it, and it just evolved from there, really. At my school, it's set up to where we have a Math 1A class, which is a slower-paced version of Math 1. And then we have a Math 1 class, which most freshmen will take, unless they take Math 1A. And then following Math 1, we have a Math 2. And starting next year, we are incorporating Math 3. So that's how it's set up here at Lewistown. And I know the name might be different in some locations, but in general, that is the setup according to the scope and sequence.
Okay, and one other question. When transfer students come into your school, how is that handled as to which class they would go? Do they just automatically go into integrated then, and then you help them adjust to where they need to be?
You know, Linda, it's somewhat like that, but as I tell you, this was also a great realization as a teacher of integrated. I had a couple of transfer students this year, in fact, and when their transcripts come in, we always, of course, examine those. But for the first time this year, I had students transfer in who had came from an integrated setting. And so their placement was not difficult. Now, it does get a little more difficult when they come in from a traditional setting. But in general, well, first of all, we have a placement test that we can administer. But to be sure, for example, if a student transfers in and has had Algebra 1 but no geometry, then that student takes Math 1, since there is a big portion of geometry covered in Math 1. Granted, the Algebra 1 concepts might be review, but that overlap is just part of the transition step. You know, we take it on a case-by-case basis using a placement test, and also considering it seems to be a pretty key factor of when they've had geometry or if they've had geometry, since we teach a big portion of that to our freshmen now in integrated math. Now, the older students, again, mostly we rely on a placement test for them. But the underclassmen, like I said, it is pretty just key whether they've had geometry or not if they're coming from a traditional setting.
Okay, go ahead.
Oh, I'm sorry. So next, we're going to look at a lesson plan highlighting the content standards addressed, and these will match the standards assessed in the summative assessment written at the beginning of this backward design process. Now, in addition, the math practice standards that are covered are checked, as well as a list of all assessments. And I want to show this to you right now. Again, here's a little practice in going to LiveBinder. For those of you who are going to explore it after we finish, so we're going to go to Math 1 for this particular unit, Unit 4. And to get to the lesson plan, we're going to click on the Lesson tab. Now, the first thing that pops up is going to be the lesson plan. So you'll just click the link above the preview, and here we have the lesson plan. I'm going to show you or talk about a few of my favorite parts of the lesson plan. Number one, front and center are the targeted standards, content standards rather, for this particular lesson. Now, I will also mention to you, as a side note, that Unit 4 was one lesson. Some units have multiple lessons. Some units are larger lessons that are multiple days. This is a larger lesson that is multiple days. Then we go down and we can see the math practice standards that are listed and covered in that unit. We have explanation of rigor, vocabulary, and a list of all the assessments. Now, a suggested sequence of tasks is often listed, and I often have other teachers ask me, do I have to go in that order? And my reply is no. We don't have to go in that order. It's just a suggestion for that particular lesson plan. Now, once again, I want to go over the steps. Find LiveBinder. You're going to look for one of two things when you find it. You're going to look for the yellow box from the ISB website, choosing Common Core ELA Math from the far right. Then you're going to stay on the far right and choose Model Math Curriculum and click your yellow box. Or Illinois Classrooms in Action.org, choose the green circle. Why would we use this Model Math Curriculum? Well, these resources can be used by teachers preparing students for PARCC. That is true. But more so, we would use these resources to assist teachers in the implementation of standards-aligned curriculum and instruction, as well as to compare when we select or design additional resources to use in our implementation. These resources are program neutral, meaning it can be adapted or used with any existing program and does not favor any program in particular. Next, it's focused only on the math needed to teach the standard, and also to remain coherent across the levels and with the topics linked together. And lastly, the rigor is expected as a balance between conceptual, procedural, and application understanding. In conclusion, we stated the targets for this webinar. We have discussed what the Model Math Curriculum is, where it is located, what is included. I have reviewed the concept of backward design for you and shown you how the assessment plan is designed, balanced, and comprehensive. I shared with you some actual student responses, and hopefully you have sensed that I'm very excited about using these lesson plans. I have seen my students grow in their knowledge of mathematical principles, but what is most gratifying is that students who have experienced challenges in, quote, getting math, are learning math and even enjoying it. The built-in scaffolding of the stations helps build their confidence as they work through the task, which for many students is oh so necessary. Another perhaps not so obvious benefit of going through this process in lesson plan development is that the teachers are thinking through the process that begins with identifying specifically what the standards indicate students should learn, and then developing a really good assessment to help us know that from the analyzed results, the student has learned the concept. The assessments also direct us to reteach what is still uncertain. The engagement in doing math by working through actual real-life tasks helps students see that math is authentic and not just a lot of problems to complete at the end of a chapter. This is the buy-in we need with students in order to move them forward to greater achievement. Please plan now to join us for our next webinar in the Teacher to Teacher series, Model Math Curriculum Resources, Backward Design Process, which will air on February 24th at 3:30.
Viewers, we just want to remind you that the handout is available. We have pushed out that address that should be in your chat box for the isb.net/webinar, where you'll find the evaluation sheet. We ask that you complete that evaluation sheet and please send it to me, and my address will be coming to you. That's lbrisenden33@gmail.com. We appreciate having your comments so that we can know for future planning where we should be going. And if you have any final questions, please go ahead and ask them now. We'll try to get them answered. We have some. We'll get an FAQ out that will have some of the responses that we may not have been able to get to during the broadcast.
We have a raised hand from Crystal Thomas. Crystal, go ahead.
Yes, I'm a high school principal, and we are piloting the integrated math program for our students, and we had one teacher to implement with fidelity. And on our NWEA assessment that we took last week, it looks like she got the highest gains.
Wow, that's great news. Thank you so much for sharing that.
But how do you get other teachers, because this means, to me, model math means you have to teach differently. So what are some of the things that you suggest I do to get other people on board?
Okay, is that for me?
For any one of you, it's, you know, what experiences have you had really trying to say, hey, this is a new way of teaching math?
Okay, I'll go ahead and start. You know, I think many districts experience just what you're experiencing right now. I guess, first of all, let me congratulate you on those great scores. That is wonderful news. But I think you can use that data to provide to your other teachers.
Okay.
You know, we are people, and so therefore numbers should speak loudly. I know that some teachers are hesitant because it does seem like a lot of additional work than what we used to do. And initially there is some time investment. But for those teachers who've been hesitant, and for other schools who have asked me, and this is something I've done in my own district, I have suggested that the teachers start by incorporating some of the math practice standards.
Oh, that's a good idea. Okay.
And when the math practice standards are incorporated, that lends activities to becoming more like tasks, just by nature, because we are persevering in problem solving. So the activities become tasks and more complex. The higher order thinking just goes along with math practice 7, justify your reasoning. And so I suggest that a lot of teachers start with that if they're hesitant. And I have actually sat down with some teachers, other districts, and picked out a few tasks for them to filter into their traditional teaching that completely align with what they're teaching traditionally, but they would use it as a special class activity. And my hope is then they use this activity, kids, you know, light bulbs come on, there's excitement and energy in the room, and then they want more. So those are a couple of things that I've done in the past.
Okay, thank you. That's a very good idea.
And Crystal, one thing that you might do, I don't know if it's possible, Anita has had visitors to her classroom, and I think that sometimes when other teachers see the excitement that the students have for doing math and being engaged in math, maybe that would also be a real positive motivator for, you know, some of the teachers as well. Watching somebody next door sometimes just isn't as exciting as, you know, watching someone else in another school do something. So we're going to have some other webinars, and maybe if you could have them tune in and learn a little bit more about it. But I do think Anita's idea of trying a task is a really good one. Anita, there was one question that came in that said, what follows Math 1A? When a student completes that, do they then take Math 1 as a sophomore?
They do. And they do take Math 1 as a sophomore. Currently here, at least, they do. So when we implemented integrated math, we had several students who had failed. At the time, it was for a pre-algebra class, and so they had failed it. So they went into a Math 1A class because they hadn't received any credits yet. Now, currently, we've left the Math 1A class as it is for struggling students. I do change the curriculum between Math 1A and 1. There are certain standards I don't cover as in-depth in Math 1A as I do in Math 1. So there are differences in the curriculum. I want to be clear on that. But in general, it is a preparation for Math 1.
Anita, thanks for sharing what's happening at your high school. How about at your school at junior high and elementary? Are you seeing changes there as well? Is your entire district embracing the model math curriculum use? Could you speak to that a little bit?
Yes, and I'm going to be completely honest with you here. It's a work in progress as we are moving down with the curriculum. I have spent some time with both our elementary staff and the junior high staff regarding implementation, and you know, I really think it goes back to Crystal's question. We really have to have teacher buy-in, and sometimes in order to get that, they have to see the students buy-in first. So just as the same as I suggested with the question earlier, I have shared tasks. I have looked up things to specifically align with certain classrooms for them to try out. We are not completely integrated here yet, but we are moving towards it. It's just perhaps a little bit slower process than I would like.
Okay, we just want to remind all of you about that there is a recorded version of this webinar. If you'd like to refer back to it or share it with someone, it'll become available within the next 2 weeks. We'll have an FAQ posted with any additional questions and responses from Anita. In the meantime, remember to complete the evaluation form for us, and please email that to me, Linda lbrisenden33@gmail.com. We greatly appreciate your taking the time to be with us today. We hope that we were able to answer your questions. Thank you so much, Anita, for your time and for the energy that you devote to teaching Illinois students. This concludes the webinar.